Welcome back, guys. So for the rest of the semester, what we're going to be talking about is a new set of functions. So we've looked at y equals x squared, we've looked at y equals x, we've looked at absolute value of x, we've looked at constant functions, we've looked at x cubed, x fourth, x fifth, and we've looked at regular polynomials. So now what we want to think about is, okay, what about something that looks a little bit more like this? So what if we have a function, f of x, right, and we go 1 over x, okay? So this type of family of functions, all right, we're going to be talking about first, all right, is more specifically, it's called rational functions. But the one we're specifically going to look at right now, because it's only one x on in the bottom, so realistically it's just reciprocal functions. So these are going to be kind of the same thing, and we're going to look at them in sort of the same way, since they're going to have a lot of similarities. Now, we're going to be graphing reciprocal functions first, just because they're kind of the easiest. Okay, so we're going to graph f of x equals 1 over x. So I'm going to move my table over to the verbal description. Remember, for the verbal description, right, you're going to want to put in you're going to want to put in your own thing. So I'm just going to make my table of values just like how we started before, x and f of x, right? Okay. And the first x that we're going to choose is, as usual, we're going to choose 0. Now the problem with this one is if I choose 0, right, 1 over 0, right, this is always going to be undefined. So we're actually not going to have this graph or if x equals 0, right, we're actually not going to be able to have anything on this graph. Okay, so what's that going to look like? Well, we'll kind of do more points, and then we'll kind of see from there. So let's start with going left or right one. So let's go to the right one. Let's go positive. So if x equals 1, 1 over 1 is 1. So I'm going to plot my first point. So I go right 1, up 1. Okay. And then now I'm going to go, okay, well, let's go 2. Okay. Well, 1 over 2 is just equal to 1/2. And so I'm going to go over 2 and up 1/2. Okay, well, as you can kind of see, the larger values of x that I get, right, the smaller and smaller my actual values are going to get. So let's try and choose something a little bit smaller. So let's go, you know what, let's go 1/2. Okay, so this would be 1 over 1/2, which is equal to 1 times 2 over 1, right, which is equal to 2. Okay, so actually at 1/2, we're going to be going up a little bit faster. And you can see that if I choose smaller and smaller values, this is actually going to get bigger and bigger and bigger. Okay, well, let's just look at what happens on the negative side. So let's go -1. Well, -1 over -1 is just simply -1. So I'm going to go -1, -1. What about -2? Well, it's going to be 1 over -2, which is just going to simply be -1/2. So it's going to look very, very similar, right, to what we have on that side. But you can see the things that we're never going to have, right? So if I do -1/2, right, this is going to be 1 over -1/2, which is the same thing as 1 times -2 over 1, which is equal to -2. Okay. So you can kind of start to see this graph is starting to look a little bit funky. All right, but one thing that we want to know or realize is that this thing's never going to touch my 0. It's never going to touch my y-axis. Okay, so what's going to happen? This graph, right, is all these values are going to get higher and higher and higher. So the smaller values of x I choose, right, the larger they're going to get, but they're never actually going to equal 0. Right, my function will never, or x can never be 0. So I can't ever choose that one, but my graphs are going to get higher. And the larger value of x that I choose, my graph is going to get smaller and smaller and smaller and smaller. The only problem is, okay, think about when will this equal 0? For what value of x, right, will y equal 0? And the truth is, it never will. Okay, because when will 1 over x equal 0? It won't. You can't. Because if I choose 0 for x, it'll be undefined. And so there's no value that I can choose that'll ever make this 0. So if that's the case, right, then I know I can never touch either the x or the y-axis. right? Which means that this one, much like its other half, is going to get really, really close to the y-axis, right, but never actually touch, okay? And I'm sorry, my drawing abilities are not that great. So this is kind of what our graph looks like. And again, you can check on Desmos if you need to. But one of the things that you're going to notice, right, since my values can never equal the y-axis to the x-axis, you're actually going to have these invisible lines here, right, that my value will never cross, or my graph will never cross. Okay? And this is the first time we're going to be, one of these things is going to be emerging, right? And both of these things are what we call asymptotes. Okay? So what an asymptote is, right? An asymptote is a line, right, in which my graph approaches but never crosses. Okay. Now, I'm going to say that never crosses. That's kind of a weird one, because there are graphs in which we'll get something, if I have something like this and I have this asymptote here, right? There are some graphs that might come up and then do something weird and funky like that. Okay? So those types of things do kind of exist, right? But we want to just think about that as never crossing for now. Okay? And that's essentially what an asymptote is. Oops. Let's see. What an asymptote is. Now there's three types of asymptotes, and we'll talk more about that later. All right, this first one, so again, it's a vertical line, right? This right here is called a vertical asymptote. And this one right here, since it's a vertical line, and this one is called a horizontal asymptote. Okay? Because it's a horizontal line that my thing will never cross. So horizontal is the way thinking about it is y can never equal this value, and vertical is x can never equal this value. Okay, so another way of thinking of horizontal asymptotes, y cannot equal 0 in this case, and our horizontal asymptote x cannot equal 0. Okay, and so let's kind of talk about the defining characteristics. Okay, the domain of this guy. Right? And this is, again, where it's going to be kind of tricky. The domain, right, is going to look really funky, because my domain is every single value. I can choose any single x value except 0. So what this is going to look like is from -infinity to 0. And it can't include, so there's never going to be brackets. So -infinity to 0 in union with 0 to positive infinity. Okay? Because that's saying, right, from -infinity up to 0, and everything from -infinity to 0 and everything from after 0 essentially will work. Okay. All right. So the range is going to look very similar as well, because again, we have our asymptote, right? That doesn't allow us. So we come from the bottom. So we start at -infinity, we go up, and then we stop at 0, right? And then we go from after 0, we go up again and stop, and go up again for infinitely. So that's kind of why our domain and range are so weird. Okay, it's because of these asymptotes. Increasing on, decreasing on. Well, you know what the interesting thing about this? So it's increasing. Right, again, we're going to move from left to right, and now we're going to have both. Okay, well, not really. I mean, so if you think about it, my function's essentially increasing. Do that. If you think about it, if you look at our kind of, again, we're going to, here, let me use a little ruler here. If we kind of look at this guy, and we kind of move it across, right, we can see that my slopes essentially are decreasing everywhere from here, right? And once again, and they're going infinitely. Once I hit 0, it kind of pauses, right? But then again, it's still decreasing this entire time, okay? So realistically, even though we kind of have that break there, right? Let's get rid of that ruler. Even though we have that break there, right? This thing is never increasing, right? But it is decreasing from negative infinity to 0, and then once again from 0 to positive infinity. So it's decreasing essentially the entire time, but because that asymptote, right, we can't just say it's always decreasing. Good gracious. Okay. Now, horizontal asymptotes. Okay. Since we do have them, okay, we need to list out what they are. So our horizontal asymptote is, at y equals 0. So essentially, this is the x-axis. And our vertical asymptote is x is equal to 0, or the y-axis. Okay. So remember, vertical lines have the form x equals h. Horizontal lines have the form y equals k. Okay. Get rid of this line. All right. Now my x-intercepts and y-intercepts. You know what's interesting about these ones, right? So if I try to solve them, right? Again, we're going to see that this is, in order to find the x-intercept, we set y is equal to 0. Right? But then we want to figure, okay, when can y equal 0? Right? Never. Okay? So so we do not have any x-intercepts. And likewise, if I want to do y-intercepts, I set x is equal to 0. But the problem is 1 over 0 is undefined. So these will actually never have x or y intercepts. Again, that's just because we have the asymptotes there. For maximum and minimum values, you can tell here that even though we may or may not have, we don't have any maximum or minimum value because x can go up infinitely. Because x can go up infinitely and x will also go down. Y will go up infinitely and y will also go down infinitely. So we actually don't have maximum or minimum values. Is it 1-to-1? Well, let's check here. All right. So again, if I do it this way, is this a function? Yes, it is. It actually does, even though this is the weird part, right? It actually does pass the vertical line test. Now that was weird. Now for the horizontal line test. For horizontal line test, let's see. We're going to go from bottom to top. Even though this one looks like it's funky, it never actually has the same place twice. So realistically, this is actually 1-to-1. Isn't that weird? Okay. So let's go turn this off. And yes, this is 1-to-1. Slope, non-linear. Vertex. Now this one's going to be kind of funky. There is no axis of symmetry for these guys. The vertex for this guy is we're actually going to use something a little bit different. We're not going to call it the vertex, again, kind of like what we did with like cubics and stuff like that. We're going to just call it like, I guess, I don't even know what you'd call it, right? But this point right here, okay, it's actually not part, I'll use a different color because it's actually not part of my graph. This point right here, the point where my intercepts cross, or my asymptotes cross, right? That point right there is going to act like our vertex. That point right there is going to be our HK every single time. And you'll see that when we start graphing transformations a little bit later. Okay? Oops. So that's actually going to be kind of like our vertex. So in this case, we're not going to call it our vertex, right, but we're going to identify that point, right, as 0, 0. Okay? And that's kind of how we can do these for reciprocal functions. And again, this is just the basics. So what we also want to look at, and the next video I'm going to show you guys a little bit Desmos so you can kind of see the transformations, and then we'll also do yet one more video in which we talk about how to graph these actual transformations. All right, thanks guys.